Warm welcome to A-Level Physics, Cambridge A-Level 2.2 Kinematics, projectile motion. This is the page on my notes. The speed of a runner is 8.0 meter per second. So this is a physical quantity that from this topic onwards we'll be defining. And we have to decide whether this quantity is scalar or vector. Right? Topic 1, we should teach you how to calculate when it's a scalar, when it's a vector. Then there must be a magnitude, and this magnitude is subjected to uncertainty, random and systematic error. That's also in topic 1. Then we must also have a unit. Okay, so from now onwards, we will just use, we have to decide whether it's a scalar or vector, and then if it's a vector, we use our vector method to calculate the magnitude. Right? If you want to find the resources, my notes, you can find in Physics AS. These are all topics. Or past year paper before 2020. Some of them will be here with more answer in PowerPoint. Or you're interested in practical before 2020 also will be here. Physics Practical AS. Welcome to become member of it. Right? If we look at our syllabus, where are we now? We are here. Describe and explain motion due to uniform velocity in one direction and uniform acceleration in a perpendicular direction. Okay, so I call it 2.2 kinematics or projectile motion. Right? For this ship, send a missile, hit a tank. What are the factors you must know? Right? We call this non-linear motion. It's not in a straight line now. Right? It's in a path, curve. But sometimes we call it motion in a plane or motion in 2 dimensions. Right? We still use the equation of uniform acceleration, which we have studied earlier. Then first we'll look at the effect of no air resistance. Then we look briefly at the effect of air resistance. Topic 3, we go into more detail of air resistance. Right? Some of the books, older books, you may find better, newer one. These are older books. These are from my notes, worksheet. Okay, so we won't bother about all this. It's a past year paper. Okay, so basically we are covering, describe and explain the motion due to uniform velocity in one direction, uniform velocity in one direction, and uniform acceleration in a perpendicular direction. That's a perpendicular direction, uniform acceleration. To destroy a tank with a missile, what variable do the captain of the ship need to consider? Right? Some of the factors we need to know: the distance of the tank from the ship, that's the range, the speed of the tank, whether it's moving towards or away, or at an angle, the speed and angle of the missile. Right? To decide this angle, send your missile hit it directly. Effect of air resistance, direction of wind speed. Okay, of course, we also have to consider whether this is a missile sent from the ship is stationary or moving, and also the movement of the tank or the vehicle that we want to hit. Some example of non-linear motion. Right? Or we call it motion in a plane, projectile motion. For example, air power rocket. Air power rocket. Other example, throwing a ball horizontally, throwing a javelin, right? Or a person diving from a springboard, firing a cannon. Okay, let's just review. This is multi-flash photograph or stroboscopic photo. Right? It shows you, right? If it's moving at 10 meters per second, it shows you the distance move every 1 second. Right? So per second, 10 meter. Second, you add another 10 meter, is 20 meter. Third second, you add another 10, 10 meter, so it's 30 meter. 4 second is 40 meter. So uniform velocity, example, a ball moving at a speed of 10 meter per second in a straight line. Distance travel every 1 second is 10 meter. Then we use our equation to calculate x equals to ux times t. That's the x is for in the x direction, right? For horizontal velocity. Uniform acceleration, dropping a ball, right? We can round it off to 10 meter per second. The velocity v increases if you drop a ball. Velocity increases uniformly. There's 10 meter per second every second. That's what it means by that. Right? Every 1 second, increase by 10 meter per second. And the displacement also increases. Yeah, summarize for you. Right? You start by dropping it at time t equals 0. Velocity is 0. Y is 0. 1 second later, right? 10 meter per second, so it will be 10 meter per second. So it has moved 5 meter. Right? It moved 5 meter. Then at 2 seconds, you add out 10 meter per second. No? Every 1 second, you add 10 meters at 20. So the distance it would travel will be 20 meter. Same. Third second, to this 20, you add 10 meter per second, so it's 30. So the distance is y is 45 meter. So you can see that initially it was 0, then 5 meter, then 20 meter, then 45 meter. Right? Y increases, normal uniform. So we use equation of motion in this calculation. Right? Where this is from the definition, this one is from the graph. These two are given in the formula sheet. Throwing a ball horizontally from a cliff. You can think of the motion as a combination of uniform velocity horizontally, like this case, uniform velocity horizontally. That's the ball. Just draw it separately. Uniform velocity. Uniform acceleration vertically downwards. That means you are dropping from rest, dropping the ball downwards. Right? There is the uniform acceleration. Gravity is pulling it down. Okay. So black. One is dropping. One is moving at horizontally. Uniform velocity. So if we are throwing it horizontally, then we will get, at any time we combine the two motion independently as vectors to find the resultant velocity. Right? Find the velocity. Right? Example, per second, it will be the red one horizontally. Vertically, we have traveled to the red one. We will move it here. The red one will be here. And another second, right? We have this one horizontally, we move to the pink circle. This one will move to the pink circle. So we move the pink circle here. So that is that's the distance move. for the path the object is moving or the ball is moving. So to find the resultant horizontal as the vertical, we have to use it vectorially. Same, horizontal, vertical, vectorially. Right? So similarly, the blue one and the blue one combine to get the resultant velocity, and also the same one, the green one is the horizontal one. Horizontal is always the same, never change. Vertical one becomes longer. Right? We look at the distance move. Or we can use a turboscopic photograph. You drop a red ball here, and you throw at the same time we throw a pink ball, right? And then we can take a photograph of it. You can see that. Right? This one is moved horizontally. That is the horizontal distance. This one is dropped, so there is no horizontal distance. A ball dropped vertically at the same time, another projected horizontally. The yellow one is the one projected horizontally. This one is dropped vertically, the red one. The distance the ball moves horizontally depends how long the ball is in the air. How far it will move this horizontal will depend on how far it's in the air. If that is the height, that's how far it will be in the air. That's the distance. Displacement. The distance the ball moves horizontally depends on how long the ball is in the air. That's on the vertical velocity. Displacement, how the ball thrown, right? Whether you throw it, whether it's this high or whether it's that high. And on its horizontal velocity, right? That distance move will depend on the height. The velocity is thrown horizontally. And also, of course, if you throw it vertically, you throw it at an angle will be completely different length altogether, horizontal distance. Right? So these are apparatus in the lab that you can use to analyze motion on an inclined plane, paper 5. Or some of you may have done it in class, in O level. We have a ball here at the edge, and another marble there. That's your meter rule. So as you hit, you slide the ball horizontal, slide the meter rule horizontally. This marble will be projected horizontally, whereas this one will drop vertically. And you'll find both of them drop to the ground at the same time. Air resistance is negligible. Right? Or you can go to this website, play with some of the video or some of the projectile motion. Right? Same place. Okay, so we just summarize general projectile motion. Doesn't have to be horizontal, can be vertical, it can be at an angle, it can be downwards. Right? But the acceleration is this way, downwards, gravity. So we usually will resolve this is velocity, right? Motion with velocity of projection. So we resolve it into two components, one horizontally, one vertically. Instead of this one, we represent it with two of them. Right? So this, as it goes outwards, because of this, gravity is pulling it downwards, deceleration. This one, uniform velocity. Right? The weight of the object is pulling it down, or gravity is pulling it down. Variation of horizontal and vertical component of velocity. Right? That's a velocity. Right? Some book will call it, instead of calling U, they call it V naught. Right? Naught is for origin, the starting point. Object thrown with a velocity v0 and an angle of alpha to the horizontal. Vx is a component of velocity. Vx is the horizontal component of velocity. And x in the x direction, y in the y direction is the vertical component of velocity. R is the range, h is the maximum height. Vox, the O is the initial horizontal component in the x direction. Okay, so we replace that initial velocity with Vox, Voy. One vertical component, one horizontal component. Then we will observe the horizontal component. Remember, we are not interested in air resistance now, no air resistance. So the horizontal component will always be the same. Even at maximum height, it will be the same. But the vertical component decreases to 0 at maximum height. Right? Then, right, this part is deceleration. This part, it changes direction, moving downwards there. So the velocity, the y component is increasing. Right? The x component is still the same, never changed. Right? So as you reach the ground, this is the ground level. Horizontal component is still the same. The vertical component magnitude is the same, but direction is downwards. This is upwards, this is downwards, same magnitude. When I put a negative sign to show it's a vector quantity, we take outwards as positive. Horizontal component of velocity Vx remains constant. Okay? That one remains constant, doesn't change. Vertical component of velocity Vy decreases as object move upwards. As it moves upwards, this component decreases to 0 at maximum height and accelerate, then it turns right? 0 velocity, then it must drop down. That's why it's increasing. Okay? And accelerate when the object moves downwards. So we are just combining example of ball moving at uniform velocity of 10 meters per second in a straight line. So the distance traveled is in 1 second is 10 meters. 1 second, 10 meters. And we combine. Right? Person throwing a ball at 20 meters per second. Right? Remember, there is the velocity vector. Acceleration is downwards. So the velocity will decrease. At height 50 meters will be 10 meters per second. Then at maximum height, which is about 20 meters, velocity is 0 at 2 seconds. You can calculate that out. Then after that, it's dropping down. Right? It should be in the same line, but it's displayed slightly to help you see it. So at the same height, 50 meters above the hand, the speed is the same. But as a vector, the velocity is downwards. This one is upwards. Right? When I reach the hand, the same thing. Right? At 4 seconds, the distance is 0. Distance is measured from the hand. Right? This is 20 upwards, 20 downwards. So because it's a vector, we put minus 20. That means we take outwards as positive. Right? So this is uniform acceleration. So basically, we are just combining this one and that one, that's all. In projectile motion, right? For projectile motion, the maximum height and the maximum range of the projectile depends on angle of projection. Theta is the angle of projection. This is the ground, horizontal line. Initial velocity, this is called initial velocity. You can put V0 or you can use U0. British use U, but American tend to use V0. Right, that's the path parabola, symmetrical, and u is called the velocity of projection, trajectory, or the path. Right? So we replace, right? Complete a rectangle there, replace that velocity with one horizontal velocity, one vertical velocity. Right? So horizontal velocity is u cos theta. Next to this angle is cos. Then this one vertical component will be u sine theta. Right? So this is uniform velocity. This one undergoes uniform acceleration. Right? This is called the range. So maximum height, we will derive in a while. There's the maximum height. Don't memorize the formula, know how to derive it. Time of flight, because there's too many formulas to memorize. You got it wrong, you lose all the mark already. Whereas if you show the working, you will get some marks there for your working. Range, that's the equation for the range. What have we done? Right? That's the vertical velocity. We treat the motion in a plane or two dimension as combination of independent. Right? They're not dependent on each other. Vertical and horizontal motion. Vertical motion, Vy or Uy, Vx or Ux. Right? If we use V, we usually follow American. To determine the velocity at any time, we just add the vertical and horizontal velocity as vectors. Right? There's a vector equation. That means we cannot just simply add numbers. We must know the direction of Vx, direction of Vy. Right? Usually we show on a graph. Remember, vertical velocity at any time is given a vector equation. This is not an algebra equation. A vector equation, that means you must know the direction of Vx and Vy. Right? This is the x component, horizontal component, this is the vertical component. Then we calculate the magnitude, V equals to Vx squared plus Vy squared, as in topic 1. Right? This one summarized to you. Determine the maximum height, consider vertical motion. To determine the time of flight, consider vertical motion. To determine the range, consider horizontal motion. Okay, let's derive the equation. Derivation of maximum height, time of flight, and range. Okay, so that is a velocity of projection. That's the angle of projection. Let's look at the physics. First, resolve the velocity of projection into its component in the x and y direction. Velocity of projection, that's your uy. That means the initial velocity in the y direction. Or vertical component of velocity. This u sine theta. And this one is ux. Right? Initial velocity in the x direction. Or horizontal component of velocity. So it's u cos theta. Theta is called angle of projection. Angle that you shoot your projectile or you throw your object. X is the horizontal distance. Maximum height, remember maximum height is determined by its component. Vertical velocity. This one determine how far it will travel. Since we are working with vectors, remember, this is a vector. We must choose taking outwards as positive and consider vertical motion. Right? Vertical component, this Vy, this is the final velocity. The y component of final velocity is 0. A is minus G, is downwards. S equals to H is the maximum height. And then this is the initial velocity in the y direction. So we choose the equation, v squared equals u squared plus 2as. Substitute into the equation, v squared is this one. That's the final velocity in the y direction. U, that's U. Square that. 2, A is minus G. S is H. Okay, so H, we can take this one to the other side, becomes positive. Then we want H, we take the 2G down. So we have that is the square. Okay, know how to derive it, no need to memorize it. Time of flight and range. Time of flight, it means the time the object or the body is in the air. So we consider vertical motion because the time of flight is determined by, as he said, the time the body is in the air. So that's our initial velocity in the y direction. Now A equals minus G. And we are interested in time. So final velocity, right, as it comes down, right? And we count down to here. That's the final velocity. It's still the same value as this one, except it's pointing downwards. This one is still the same. Okay, so we replace the velocity of projection with the initial component in the y direction. So the body returns to the ground with the same speed, but in opposite direction. That's why you put a negative sign to show it's a vector. These are all upwards. This is downwards. And choose the equation. Right? Substitute V is just that. U is just that. A is minus G. And then the T is the same, the time. So we take this one over there. This one will add to that one. So we get 2U sine theta. So we want to find T, we take the G down. We get our equation. Range. Right? That's what we have determined. Time of flight. Right? Remember, range is the distance traveled horizontally when the body returns to the ground. Right? From the starting point to where it comes, return to the ground, that's the range. So we consider horizontal motion. Remember, horizontal motion is uniform velocity. The distance is speed times time, that's all. Right? R is initial speed in the x direction times your time. R for range. The horizontal component is that one. U cos theta. Right? That's the time of flight. Put it inside there. So we are just using the substitution. 2 cos theta sine theta equals to sine 2 theta. That one. 2 sine theta cos theta. So we get our U, and U is U squared. Cos theta, 2 sine theta becomes your 2 sine theta, and that's your G. Right? Remember our formula doesn't apply to here. Apply to this one. Same level. Range. That's the range. Right? You want to find maximum range? Sine 2 theta. The largest value can be is 1 only. 1. where the range is maximum. So in this case, sine 2 theta equals to 1, 2 theta equals 90, theta is 45 degrees. That angle must be 45 degrees for maximum range. Right? Remember, this is on the same level. Not this case. So that is 1. So you got u squared g. Right? As I said, do not memorize the formula, but know how to derive them. Understand the physics involved. Right? Fifth point, time of flight. Time of flight, time the object is in the air, equals to 2 times 2 times time to reach maximum height. Right? The time to go up and the time to go down is the same. Effect of air resistance on the path of object. Right? Without any air resistance, the resultant force acting on the object is the weight. The weight only. That's gravity, G. The upward acceleration or upward when you throw the ball upwards or drag at an angle, when you move upwards, is deceleration. When you move downwards, is acceleration. Right? This part is deceleration. That's the maximum height. This part is deceleration. Right? Both have the same value for G. Vertical motion, when moving upwards, right? We look at the effect of air resistance. When moving upwards, the cannonball would encounter greater retarding force due to weight and air resistance. Right? The next topic, we'll look at that one. So the weight is pulling it down, weight, and air resistance, because it's moving upwards there, air resistance is opposing it. It's also opposing it horizontally. Right? It's moving horizontally, air resistance is that way there. Right? So the retardation, deceleration is very great. So we can expect it won't reach the same height. It won't reach the same height. Okay, it will reach a height at a different time, shorter time, maximum height. Vertical component of speed decreases much faster because of greater acceleration. Vertical component of speed decreases much faster. Thus, maximum height will be lower. Right? Whereas when it's moving downwards there, the weight is going down. Air resistance is upwards. So the resultant force of acceleration is now smaller. No more G, smaller than G. Right? This one is greater than G. Right? The acceleration is greater than G, or the deceleration is greater than G. So the path is no more symmetrical. The effect of air resistance, that's the actual path. And it can be vertical if you have reached terminal velocity. Right? Because remember, air resistance doesn't affect the vertical component when it's moving outwards yet. It affects the horizontal component also. Horizontally, the ball is subjected to deceleration due to air resistance. Speed of the ball decreasing. Right? Doesn't remain unchanged, not uniform anymore. The range of the ball will be shorter. Right? So the path is no more symmetrical anymore. Right? That's the effect of air resistance. Okay, let's try some question. Finish the topic. A stone is thrown horizontally from the top of a cliff. That's the cliff. That's your stone. With a velocity of 20 meters per second. The stone reached the sea. At this point, I reached the sea in 3 seconds. Calculate the height of the cliff the distance from the cliff at which the stone strikes the sea. We want to find the range, that distance, and find that height. The vertical velocity of the stone when it enters the sea at this point, vertical component velocity. The resultant velocity of the stone before entering the sea. Okay, let's do one by one. Height. So we consider vertical motion. Right? Remember, 20 meters per second is the horizontal velocity. So vertical velocity is 0. Right? 20 is the horizontal velocity, not vertical. Vertical will be 0. That is your range. Right? So the range should be from here, where the ball stands out. That's the vertical height. Vertical height of cliff is determined by vertical motion. So we have to consider vertical motion when to find the height. Remembering that we are dealing with vectors, so you have to choose the direction. That is our choice. We can choose upwards as positive, but usually we prefer to deal with positive rather than negative. So we take downwards as positive. It's our choice. It's not that it's wrong. It's our choice. Right? We are given initial vertical speed is 0. Right? It's just like dropping it because horizontal is 20. Then A equals to G is 9.81. You cannot use 10. You must use 9.81. And then we are told it's 3 seconds. And then the height, H is S equals to H. So we choose the correct formula, S equals to UT plus half AT squared. Put in the value. S is your H. Initially is 0. Half A is 9.81. T is 3 seconds. So using calculator, we get 44.1. Right? You can write as 44 if you want to. Right? The next part is we want to find the distance from the cliff. Right? If the ball is sent out from that height there, then there is the range that we are interested in. Since we are calculating horizontal distance, we consider horizontal motion. Right? That speed determine that distance. Right? So uniform velocity times that times time, 20 times 3 is 60 meters. Vertical velocity, where I reach here. Right? So we consider vertical motion. Consider vertical motion. Note down what is given. Right? First thing, note down what is given. Right? It's just like dropping a ball. Initial speed is 0. Acceleration, we take downward as positive, is 9.81. S is 3 seconds. And we can calculate our V. Choose the right formula. Put in the formula, calculate out. Right? So it has a direction. This is downwards because we take downwards as positive. Resultant velocity, so that is 20. 20 is the same. It doesn't change. Horizontally, it doesn't change. There's no air resistance. Vertically, it's 29.4. So we form a rectangle. That's the resultant velocity. Final. We put F there to show it's a final. It doesn't matter. It doesn't have to put the F there. V is good enough. Then that's the angle, alpha. So we draw that. That's your 20. That's your 29.4. That's the final velocity. That's your alpha. So horizontal velocity is constant. Magnitude, using Pythagoras theorem. Right? This is a right angle triangle. 20 square plus 29.4 square. Square root that. Then 35.6. Direction, We have to find this angle there. As long as you show the diagram, the angle is good enough. Tangent alpha is 29.4 divided by 20, 7.47. Alpha is 55.8. Usually exam you are required only two significant figures. Right? Remember, we must add vectorially. We cannot just add these two together. Right? We must draw a triangle, a right angle triangle we use Pythagoras theorem. Okay, let's try another question. A baseball is thrown with an initial velocity of 100 meters per second at an angle of 35. Right? Draw a rough diagram so that you, in the mind, you know what you're doing. There's the ground, there's the velocity of projection, there's the angle, 5.0 degrees. Calculate maximum height, time to reach maximum height, time of flight. Okay? So first thing, resolve it into its component in the x direction. Right? Initial speed in the x direction is u cos 35. Then you got your uy is 100 sine 35. These are the two that we are using. Maximum height, we consider vertical motion. Consider vertical motion. Right? So it's easier to take outwards as positive, but it doesn't mean that you have to do that. You can take outwards as negative. Right? It's called convenient because we start with that. Put positive here. Right? Outward as positive. As vertical component of velocity. Calculate out using calculator. Right? G is downward, so you get a negative sign there. At maximum height there, vertical velocity is 0. And then s equals to h, choose the formula. V squared is u squared plus 3s, put it to the formula. Right? V is 0. U is that one there. Square that. 2a is this one, minus h. Calculate your h is 168 meter. Right? Maximum time to reach maximum, the same thing. Consider vertical motion. Right? That's what we have calculated there, uy for this one. We calculated previously. This is negative because this is downwards. This we take outwards as positive. Maximum height, v equals 0. E equals to, that's what we're going to find. So choose the right formula. V equals u plus 80. Put in the formula. Right? V is 0. U is 57.4. G is minus 9.81. That's your time. But from that, can calculate your time. 5.85 seconds. Right? So we have calculated time of flight. It's just double. Time to reach maximum height. Range. How to calculate the range? Right? Remember, range, we only consider horizontal motion. That's a horizontal component of velocity. Solution, time of flight, length by 7, which we have calculated earlier. Range of ball, consider horizontal motion. Distance is horizontal component of velocity times time. Remember this uniform velocity. So that is this one. That is the time of flight. Using calculator, 958 meter. Velocity at 5 seconds. Right? We consider vertical motion. Vertical component of velocity. right? That's the initial velocity, right? We have calculated out. Okay, we just calculate this one out, that's all. And ours with negative sign there, 5 seconds is what they want. We want to find V, vertical component of velocity. Choose the right formula. Put in the formula, that's your U. A is minus 9.81, T is 5 seconds. Using your calculator, you get 8.35 meter per second. So give you a rough direction, draw a rough sketch. There's a vertical velocity, right? It's positive, so it's upwards. Horizontal velocity, right? You can calculate out. Horizontal velocity is 81.9, right? Vertical velocity, we can, as I said, we can refer to our question earlier. Oops. Right? That's our vertical velocity that we have calculated out from here using this formula. So that's the horizontal velocity in the right angle triangle. So that's the resultant velocity and at an angle alpha. Resultant velocity used Pythagoras theorem, 8.35 square root of 8.35 square plus 81.9 square. Okay, out and direction. Use tangent alpha is 81.9 divided by 8.35. Alpha is 84.2 degrees. Good enough. Okay, let's try it. This is 2002 November, number 8. What's your question? A projectile is launched at point O and follow the path OPQRS. OPQRS. As shown, air resistance may be neglected. Which statement is true for the projectile when it is at the highest point Q of its path? The horizontal component of projectile where acceleration is 0. Is it correct? Acceleration doesn't switch off. It's always there. It never goes to 0. Horizontal component, that's for the vertical component. Horizontal component of projectile acceleration is 0. Horizontal direction, there is no acceleration. No air resistance, uniform velocity. So that's the answer. Horizontal component of projectile's velocity is 0. Sorry. Horizontal component of the projectile velocity is 0. Horizontal component doesn't go to 0, only vertical component go to 0. Kinetic energy of projectile is 0. No. Right? It has a velocity, horizontal velocity, so kinetic energy is not 0. Momentum of projectile is 0. Momentum cannot be 0 because it still have horizontal component. Right? Answer is A. Horizontal component of velocity is constant as air resistance is neglected. Horizontal acceleration is 0. Okay, let's try another one. Let's try a partial question. paper 22. Distinguish between scalar quantities and vector quantities. Right? The question can make topic 1 and topic 2 together. Distinguish between scalar and vector quantity. The scalar quantity has only magnitude, while vector quantities have magnitude and direction. 2 mark, 2 point. In the following list, underline all the scalar quantities. Right? Underline that. Power, the others are vector. 1 mark only. A stone is thrown with horizontal velocity of 20 meters per second from a cliff top at a height of 15 meters high. The path of the stone is shown. We draw the diagram. There's the cliff, there's the ground, height 15 meters. Air resistance is negligible. For this stone, right, this is 2011, June paper 22. Calculate the time for the ball. Calculate the time to fall 15 meters. So remember, we are interested in the time, so we calculate vertical motion. Vertical height is given. This is horizontal velocity, so it means the vertical velocity is 0. So consider vertical motion and downwards as positive. Height is 50 meters. Vertical velocity initially is 0. Since we take downward as positive, 9.81 is downwards. I want to find the time. Choose the equation correctly. S is ut plus half at squared. And put in your value. S is 15. U is 0. So it's half, 0.5. A is 9.81. T squared is what you want to find. For using calculator is 1.7 seconds. Calculate the magnitude of the resultant velocity after falling 50 meters. Okay, so we calculate this initial velocity doesn't change, but initial horizontal velocity doesn't change, whether initially or finally. And velocity finally, that is what we have to find, the y component. And then taking, right, when to calculate vertical velocity as we reach the C, so we calculate the vertical velocity. Right, same, what the given as before, use whatever is given as before. Right? We have already written that, no need to write this again. It's already written there. Right? 50 meter G U is given. So we want to find V, that's all. So we choose the right equation. V squared is U squared plus 2AS. U is 0. 2, G is 9.81. I is 15. We calculate 17.16. 17.16. So complete the rectangle. Resultant velocity, V square equals to 17 square plus 20 square. So V is 26. Right? We want magnitude only. We don't want direction. Describe the difference between the displacement of the stone and the distance traveled. Okay, distance is the actual path traveled. Displacement is the straight line distance between the start and finish point in that direction, or the minimum distance. Right? That means if you are required to draw, there's the displacement, there's the distance. Right? That's the ground. So that's the end of the lecture. Thank you for your time. See you again for the next topic, which is dynamic.